investigating what an ultrafilter is, and it's and the reason I'm doing it is I want to investigate it and its relation to Gödel's ontological argument, believe it or not. So, um, so we're actually trying to verify this claim that the positive properties that that we were saying there were these positive properties, and if we were trying to see if and then they were defining God as something that possessed all the positive properties, and then we proved those positive properties existed, and we proved this particular definition of godlike thing existed, and so phrasing these, it was originally phrased as perfections. Phrasing them as positive properties and axiom, giving them these axioms is particularly interesting because they're related to something um, called ultrafilters. So ultrafilters are some sort of maximal filter, and a filter is something defined on an partially ordered sets. Okay, and what I'm really interested in is what that. So the example I'm particularly interested in is the partially ordered set of the power set of a set. So you take any set, the power set of that set is defined to be the set of all subsets of the set. Okay, and then we sort of pick um, some of those subsets and we say that they form a filter if they satisfy these conditions. And the set of all subsets, the less than or equal to the partial order, is just inclusion of sets. So instead of saying z is less than or equal to x, we say a set z is contained in the set x. Okay, and that's a partial order. So if you look at this, for every x and y, so every two sets in this filter, there's a third set that's smaller than both of them. Okay, so that's kind of going to be like the intersection of the two sets. That's the common overlap of the two sets. And here's another one. It's like if one set is in the filter and something else contains it, then that thing is also in the filter. Okay. Um, so another way of these axioms applied to the power set is said more explicitly here. So anytime you have two things in the filter, two sets, the intersection is also in the filter. And anytime you have something that's in the filter and something bigger than that, then that bigger thing is also in the filter. Okay? So maybe something to help remember this is a filter is sort of like a way of nominating which subsets are big. Okay? So, if a subset is big and something else is even bigger, okay, then that bigger thing is also big. Um, if you have two things that are maybe not even big, but like extremely big. So if two things are extremely big, then the intersection um, should also be extremely big. Or actually, maybe more than saying extremely big. Say like it's almost the whole thing. It's at least almost the whole thing. So if it's at least almost the whole thing, then an interesting property is that the intersection of two of those is at least almost the whole thing. Okay, and so at a consequence of the second property is that the whole set. So if it's a power set of S, then S is a member of every filter. Okay, so that's what a filter is. and an ultrafilter. So we have what a filter is. An ultrafilter is the biggest possible. So there's no other filter that um contains the filter. So it's an ultrafilter. There's no proper subfilter. Yeah, so I mean the whole power set is, I guess, trivially a filter, and we're not really interested in that one. If there's something that's not that one and contains your filter, then your filter is not an ultrafilter. So an ultrafilter is something that does not have anything, no proper filters containing it. Okay. So yeah, here it is. Special case ultrafilter on the power set of a set. The empty set is not an element of U, so that's just saying it's a proper filter, because if the empty set's there, then every set will be there, right? Because everything contains the empty set. If A and B are subsets, the set A is a subset of B. So that's just the filter axiom, where the bigger thing is also in the filter. 3 is another, just the filter property, the intersection is contained. 4, if A is a subset of X, either A or its complement is in the ultrafilter. So that's, I guess, something to do with it being maximal, okay? Because that wasn't one of the axioms of being a filter. And okay, and I'm not sure if we're interested in verifying this at this point, or if we're interested in kind of just keep going to relating to the positive properties. Okay. I suppose the claim here is that if there was some subset that was not in the filter and its complement wasn't in the filter, we can extend our filter to a bigger filter somehow by including either the set or its complement. Okay, so okay, let's relate this to the positive properties. So this may take a little bit of explaining. So I guess if you had, so originally we have logical statements, and we're saying that the logical statement is either a positive one, so properties, either a positive property or it's not, or it's so it's either it's a positive property or not. The property is either positive or its negation is positive. Okay, so this kind of looks like this one. It's something is either in the filter or its complement is in the filter. Okay. If something is positive and another property is implied by that property, then the other property is also positive. So that's like this one here. If you have one set that's large and in the filter and another set that contains it, then the containing set is also an element of the filter. Okay. And yeah, that's at least the only two properties. Yeah, and then the intersection of two things is also um, a member. I guess that's the axiom that that sounds like, because godlike is being defined as having all positive properties, and having all positive properties is itself a positive property. Okay, so that's like saying, okay, so that's sort of the extreme version of this, that like the intersection of everything, not just two things, is in your is a positive property. So it's in your filter. So there seems to be some analogy that maybe we could relate them more explicitly. So we can consider a set, the set of things that we're talking about. Okay, the things, the subject matter. So things which are eligible to have properties. So the set of all, say, these kind of x's, where we can sort of have them satisfy a property or not satisfy a property. Okay, let's consider a set of those kind of things. Maybe it's easy if we just consider the set of natural numbers or something. Anyway, so have a set of numbers. We can consider sort of properties to be like functions from from that set to sort of the set of true and false. Okay, so logical statements basically. We were talking about this at some point, but um, I'm gonna run out of batteries. So we want logical statements. So basically, um, it's a way of so logical statements or properties are ways of saying um, basically ways of dividing the whole set into two subsets. One of the subsets is a subset of things for which the property applies to, and the other subset is the thing which the property does not apply to. So the true set and the false set. Okay. And if we look at then the set of all subsets, and we have a filter, okay, so we have some special subsets which are considered sort of almost everything, and these correspond to a bunch of statements where so each statement so each subset is the true set for each of the statements. Okay, so for example, um, the whole set, the trivial filter is just the whole power set. Okay, that's all the subsets of your set. Okay, and I guess each subset is the true value of some. Maybe you can make a trivial statement, so like x belongs to that subset. So x belongs to that subset is true if x actually belongs to that subset, and false if it doesn't. So the true it's true on that subset. Okay. When you have that, okay, so now we have a filter which is a distinguished bunch of these subsets, which corresponds to a distinguished bunch of logical statements. Okay, but they have to satisfy some properties. So can you see that? First of all, to be a distinct, so something, every set is either in the distinguished set. So here, every set is either in the distinguished set, so it's either in the filter, or its complement is in the filter. So that's like saying the statement. Every statement is either um, sort of every statement. The true set of every statement is either in your filter, or the false set is in the filter. So either the statement is true on your set, or its negation is true on your set, and one of those belongs to the filter. Okay. So basically, what I'm saying is the when you have a filter of subsets, the 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 statements which correspond to that filter are exactly the set of positive properties which apply to that set. Okay. So let's have a look at another one. So the inclusion property. So if one statement implies another one, okay, that means, so if one is true, then the other is true. That means that the set for which the first one is true um, is contained in the set for which the other one is true. Um, maybe it's the other way around. So hmm, yeah. So if the first statement is true, and if the first statement implies the second statement, then the set of things for which the second statement is true contains the set of things for which the first statement is true. Okay. So can you see that if the property is positive and something's implied on that, then the other thing being positive is the same as saying if the subset is contained in a bigger set, then the bigger set is also a member of the filter. Okay. And what else? Okay, and then this idea of the intersection of two positive properties is positive. So if two properties are positive, saying that something satisfies both those properties is a positive property. Sort of, and this is obviously, so when something satisfies both properties, it's in the intersection of the sets for which the properties, the true sets of each of the individual properties. Okay. So having done that, I think the next step I want to investigate is what makes, so if we accept that this ultrafilter of sets um, has corresponds to the positive properties, okay, then um, I sort of want to know what the godlike element is when that's the case, and it seems like, so I guess the principal ultrafilter is something that has the least element, and this might be gotten from intersecting all the things in your filter, and it's starting to look like that that um, so that thing is the supposed existence of this godlike element. So I'll just pause it right there. I have to do something.